Hi and welcome. I'm trying to learn cytology, today osmosis, and after we've done that, we're going to do extensor carpi analysis, strength training, and if you participate in the extensor carpi analysis strength training, then it's with your Osmosis. Osmosis is the net movement of a solvent through a selectively permeable membrane. Osmosis is what is coming through, that is called it. So it's not the traffic or the amount of passengers or of cars going through something, not the rate or the amount of something used in traffic. It is called osmosis, and that is just the stuff passing out of the water. So the movement is called osmosis. They are not driving in or whatever, they are osmosing in. Okay, osmosis is the coming of things into the cells. In living systems, the solvent is water. Of a solvent, is it always water? Okay, water. Which moves by osmosis across plasma membranes from an area of higher water concentration to an area of lower water concentration. Water is spreading, it goes where there's less water. And water is the solvent, when water is going into a cell, that is called osmosis. Another way to understand this idea is to consider the solute concentration. In osmosis, water moves through a selectively permeable membrane from an area of lower solute concentration to an area of higher solute concentration. So water is coming through the selectively permeable, so for some things it is permeable to go through. Water is that, so we were talking about in the previous part about the membrane permeability, or somewhere, we were talking about whether water is charged or something, or what it was, and therefore water would not go through the cell, through the lipid, because the lipids are hydrophobic. With the heads, the phosphoheads of the phospholipids and of the glycolipids, it is a glycerol head, they are all hydrophilic, but the fatty acid tails of them, they are hydrophobic and they are standing like that, the tails in the center. So why should water pass through them if between all these tails, which are the membrane is not a fixed thing like the skin, it are just a bunch of lipids standing around it, like air balloons are they. And so water can't pass through it because in the center is hydrophobic and water is charged, or whatever was the reason, but they're saying it can go through. And they said there, as a speculative hypothetical idea, maybe, how about that? It is because water is so little that it can just pass through, like slipping through it when they're moving around. All these lipids are not fixed and firm, they are moving around all the time. And they're saying maybe it comes through them. Now we're talking about osmosis, and we're talking very specifically about water. Let's read on. Water molecules penetrate plasma membranes in two ways, via diffusion through the lipid bilayer, as previously mentioned, and through aquaporins, transmembrane proteins that function as water channels. So the same channels as we had here as channels. So channels which selectively letting a substance through. And there's one which lets water through. And the other thing would be the diffusion. I don't really know what the word diffusion means. I think they mean what I just said, that it just slips through it. Osmosis occurs only when a membrane is permeable to water but not to certain solutes. Is water not the solvent but not the solute? The solute is it now mixed up in it. Solvent is the thing which should be mixed. Why should it be permeable to water, but not to some solutes? Let's read on. A simple experiment can demonstrate osmosis. Consider a U-shaped tube in which a selectively permeable membrane separates the tube's left and right arm. We're talking about something like that. I think, I don't know. Consider a U-shaped tube in which a selectively permeable membrane separates the tube's left and right arm. Okay, and the bottom there's a selectively permeable membrane. Let's say we have put a piece of paper in it. So we had with a U-shaped thing, and when we put a piece of paper in the middle, and then I had two substances on both sides. So consider the U-shaped tube in which a selectively permeable membrane separates the tube's left and the right arm. A volume of pure water is poured into the left arm, whatever, and the same volume of a solution containing solute to which the membrane is impermeable. And the same volume of a solution containing a solute to which the membrane is impermeable is poured into the right arm. Impermeable, that must mean it does not pass through. So the solute is not passing through it. Because the water concentration is higher on the left and lower on the right, the water concentration to the mean is higher because one part of the total volume is taken up by the solute. A U-shaped tube in which a selectively permeable membrane separates the tube's left and right arm. A volume of pure water is poured into the left, and the left is the water, and the same volume of a solution containing solute to which the membrane is impermeable to poured in the right arm. Because the water concentration is high in the left, yes, in the right there's also a part of it is the solute, not the water. So there's whatever in it. Can we say sand? But sand is not diffusing what is called in water. On the left, on the right, the net volume, because water concentration is higher on the left and lower on the right, net movement of water molecules, osmosis, occurs from left to right, as water moves down its concentration gradient. From left to right? From left to right. Okay, I think I understand it. In the left one is the pure water, and the other one is water, but 10% is, we have to find something, is dirt. It's so sediment, which I no, it doesn't really, yes, dirt. And there's no more water, we're on the other side. And water is now moving from the left one over to the right one. Because there's less water in the other one, because there's water plus something is volume there. So it has both the same volume, but the water is still moving. Is it able to make that in an experiment? But what is not going over? There has to be something go back because the volume is the same. Or just off what? No, the solute cannot go over. How can it go over? Because the water concentration is higher on the left and lower on the right, net movement of water molecules osmosis occurs from left to right as the water moves down its concentration gradient. At the same time, the membrane prevents the effusion of a solute from the right arm into the left arm. As a result, the volume of water in the left arm decreases and the volume of solution in the right arm increases. As a result, the volume of water, including this solute, in the left arm decreases and volume of solution, in the left was just water, and the volume of solution, so both water and the solvent in the right arm increases. So at the end of the day, one of the two is higher filled up as the other one. Let's take our sand example. What if we have filled the half of the right tube with sand, and then we have the same volume in it, sand plus water and water? Then the water on the one side would press down and go over to the other side, and the other one would be then higher up as the other one, or it would not be higher. I don't know. I'm not able to understand in the natural world. I know what we say, but I can't really imagine it. You might think that osmosis would continue until no water remains on the left side. That is the obvious conclusion. It goes completely over for whatever reason. It doesn't make sense. But this is not what happens. In this experiment, the higher the volume of solution in the right arm becomes, the more pressure it exerts on its side of the membrane. Pressure exerted in this way by the liquid is known as hydrostatic pressure, and it forces water molecules to move back into the left arm. Yes, as I say, it might pressure over, but the gravitation is pushing it back again. Why is it happening? Or is it happening so small that it is not visible? Or is sand just the wrong example, that there's not really a possibility for a natural explanation? That's not occur in nature, or even in an experiment. How big would the difference be? Are we talking about a centimeter or something, or are we talking about some hypothetical? We have calculated it, but there is a difference, but we can't see it. Forces water molecules back into the left over time. Equilibrium is reached when just as many water molecules move from the right to left due to the hydrostatic pressure as move from left to right due to osmosis. Okay, we're going to read the one. If you were here for cytology, you're going to read the next part of cytology, where we're going to read on. If you stay here and participate in the extensor capillary strength training, then is that your honest. Good and steady stand, arms up, hands from the fists, and bring them down. And up. And fists like that. Down. And up. And now you can use a sock, or a t-shirt, or a towel. You participate with it at your own risk. Press onto it and bring it down. We have 3 rules. The first rule is that we're stopping immediately as soon as there's pain. Okay. The second rule is that we're going only as far as we can go with a little bit of effort. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. Again. Change. And stand always good and stable. Yeah. And we are press and turn to the outside. And change and press and just press on top and down and again. The arm, press and down. And now just press, release, and press, and release. And that was the extensor capillary strength training. Thank you very much, and until next time.